Today I'll talk about limiting and excess reactant. First, what is the definition of limiting reactant? The reactant that is completely consumed first in a chemical reaction, limiting the amount of products formed. The reactants used up first and stopping the reaction. One consumed, no more products can be formed. So that is the definition of limiting reactant. Now excess reactant. The reactant that remains after the limiting reactant is completely consumed. Means the reactant that remains after the limiting reactant is completely consumed. Remains after limiting reactant is used up. Present in greater quantity than needed. Now, what are the key points? Limiting reactant determines the maximum yield of the product. Excess reactant is left over after the reaction. Now, how do you calculate percentage of excess reactant? So, actual amount present minus theoretical amount needed by theoretical amount needed into 100%. Now, I'll see limiting reactant and excess reactant with one example. Now, here is the example. Consider the balanced chemical reaction. So, that is 3H2 plus N2 that will produce 2NH3. Hydrogen and nitrogen that will produce ammonia. So, this is the balance equation. So, 3 hydrogen here. So, 3 hydrogen here, 2 nitrogen, 2 nitrogen. Okay. Now, let's say 5 moles H2 and 5 moles H2 and 3 mole N2 are present in the reactor. That is given. Now, if we calculate stoichiometric ratio of the reactant, means hydrogen and nitrogen, so that ratio, this is stoichiometric amount and this is also one is stoichiometric quantity. So, H2 by N2 theoretical will be 3 by 1, so that is 3. Now, ratio of the reactants in the reactor H2 by N2 actual, so that will be 5 by 3, so that is 1.667. So, now here you can see H2 by N2 theoretical greater than H2 by N2 actual, means if that condition is satisfied, and if this is the condition, then we can say N2 is in excess. If things are opposite, so we can say that H2 is in excess quantity, or we can calculate other way. So here you can see that 3 moles of N2 present, but actual requirement is 1.667. So obviously N2 is in excess quantity. Now, limiting reactant. So here, as N2 is excess quantity, obviously other reactant H2 will be the limiting reactant, because it will be run out before N2, means H2 will be finished but N2 will be still there in the reactor. Now, already we got the excess reactant and limiting reactant. Now here, excess amount of N2, how do we calculate that? So we already know that theoretical amount of nitrogen needed is 1.667, but originally that 3 moles of nitrogen is present in the reactor. So what will be the excess? So 3 minus 1.66 is equal to 1.33 moles. Now how do we calculate percentage excess of the reactant? So already we know the definition. Oh, here I have already written the definition. So actual amount of the present minus theoretical amount needed by theoretical amount needed into 100%. Now we plug all this value. Actual amount is 3. Theoretical amount needed is 1.67 and theoretical amount needed 1.67. Now if I do the calculation, we will get 79.64%.